Okay, and what I'm going to do is I'm going to record this just so that we have these notes for a second time, if you'd like to. So what is experiment one? So first of all, experiment one is found in the experiment one module. And if you go to the homepage, there's an experiment list where you can start it. You should have already taken a look. I opened it over the weekend for you to do a few things, get things ready. One thing to note about experiment one, so experiment one is all about taking quantitative observations, measurements. And so in this at-home version of experiment one, we're going to focus primarily on the ruler. So I asked you to get a centimeter ruler. This one has both centimeters and inches. Ignore the inches. We're only going to use centimeters. So that is a sort of prerequisite material that you should have. You already looked at your ruler by performing part A of experiment one. That's just to make sure that you've interpreted the tick marks of your ruler correctly. So what you're going to do, and we'll return to that in a moment, talking about experiment 1A and what we should have sort of taken from that exercise. What you'll need for experiment 1 are 3 different kinds of objects. 2 of them being 2 distinct, somewhat large, because we want to be able to practice using our ruler, you know, to its scale. It's rather large objects. They should be rectangular. This one is more of a cube, but that's okay. Any kind of sort of rectangular object. So you'll need 2 of them, and you're going to be performing some measurements on them. So you're going to be using your ruler to measure the lengths of things. The third object is going to be a cylindrical object. So this is, again, to your discretion, finding a relevant object. It could be like a can of soup or something, or any kind of container that looks like a cylinder. So you'll take those 3 objects, and in experiment 1, it's going to describe what measurements you're going to be taking. It probably isn't a surprise that these are going to be length measurements. So you're going to be practicing lining up the ruler and taking down these measurements. Now, one thing to be very careful about experiment 1 is that after you write down, after you use your ruler, you're going to have to write down the measurements on your report sheet. That's going to be the linked sort of report that's part of the module. So I want us to be very careful about how we are going to write recorded measurements every single time. And so just to practice one more time, and again, this was something that I was trying to emphasize in part 1A, is that if I have, say, a ruler, and I'm just going to go ahead and draw it, I'm going to zoom in. And just for the sake of pretend, so let's say that we're at the 4 mark. 1, 2, 3, 4, 5. 1, 2, 3, 4. And that's 5. And of course, it goes on in both directions. ... So one thing that I want to emphasize is that we are comfortable using the tick marks to decide how many digits do I need to put down for my measurement. And so the rule is, first, start by seeing what's the smallest increment, so the smallest spacing that you can read with the tick marks. So your centimeter ruler should look like this, and I'll go ahead and double check your part 1A with your ruler to double check, but pretty much every centimeter ruler has this, this type of graduation. So what is the smallest increment that we are counting, the smallest digits place that we're able to count using the tick marks themselves, meaning I'm just looking at the lines and I'm able to count in units of, is it 1, 2, 3? Is it 0.1, 0.2, 0.3, etc.? That's the first thing. So for this kind of ruler, which digits place are we going to be able to see with our eyes with the tick marks? So here's my decimal place. So which digit is it? The 0.1. The 0.1 being the 10th place, right? Because each one of these is 4.1, 4.2, 4.3. So that means that this and all above digits, those are my certain digits. That means that for this particular instrument, we're always going to go first by counting the tick marks to get to the 10th place, the first decimal place of the instrument. Now, there's one more thing that we have to be careful of, and this is probably the trickiest part, is that no matter where or how we use the ruler, we can always go further by using the fact that the instrument has been specially made that the space between the lines is important. That's the whole reason why they're carefully made, because we can actually use the little space in between. That means we can go one digit beyond what the tick marks are counting. So we've just identified that the centimeter ruler goes by 0.1, 0.2, 0.3. So it goes all the ways to this point. But because there's a little bit of space that's been specially designed by the manufacturer, we can estimate that little bit further. That's our next digit. So this is our estimate. What this means is that to use this ruler properly, we will always be using the tick marks to get the first digits, first decimal place, and then using our own intuition, I suppose, to estimate the next digit. And that's because sometimes an object, let me erase. Sometimes an object might be in the little space between two lines. And that's the most obvious reason, or that's the most obvious example of why we would want to go further, or why we are able to go further. Because if our object were in between that little space, then that means we could guess what that next little digit is by sort of thinking about, well, if it's over halfway to the next digit or less than halfway to the next digit, we can give our best estimate of what that is. So the point is that your centimeter ruler, because of the way it's been designed, can go to 2 decimal places always. So that's the first thing. The second thing is to be careful about when we are measuring something that is on the line, because that's the next kind of tricky part that students have. So if I were to 4, 5. And what I mean by that is, what if the object that I was measuring the length of, I felt like we were right on the line. So in this particular case, I'm going to go back to the rule is always the rule, and we never bend the rule. So this might be the hardest case to do. What happens when the measurement is right on the line? Well, according to my rule, I always have to go to 2 decimal places. Okay, so that means what happens if I have this scenario in my lab report? Well, we're going to do the exact same thing we've been doing. We use the tick marks to get as much information as possible. So it's right here. So I see, because it's between the 4 and the 5, it's 4.1, 0.2, 0.3, 0.4, 0.5. 4.5 is certain. But because of our previous discussion, we need to go one more place. We must go one more place. Why? Because that's how confident we are in the number. We can go to 2 decimal places. So what happens if we're on the line? Well, what should I write there? It's going to be a 0. So that's what happens when we're on the line. If you need to estimate the space in between, but you say to yourself, wait a minute, I'm not in between. Well, you still have to write a digit because 4.50 does not have the same confidence as 4.5. Notice without the 0. So those are, in the eyes of scientific notation and significant figures, those are different numbers. 4.5 is not the same as 4.50. Our ruler is telling us we are accurate to the hundredths place. So that always needs to be conveyed to the audience that I'm not going too far or too little with my significance. I always use the same thing. So even if it's on the line, we don't pretend that that digit isn't there because that's not the same level of confidence as it was before. So when we are on the line, we're always going to put 4.50, or we'll use a 0 for that because that 0 after the decimal point is significant. So we want to make sure our audience always understands how confident we are with this ruler. This ruler will always go to 2 decimal places. So that's the one thing to be careful of in the experiment, to always make sure you're recording correctly. I think for a lot of us, measuring things with rulers is something that we've done before. So again, the emphasis isn't on just give me lengths, but rather write them in the way that we've been practicing with significant figures and correct digit places. So that is going to be the first thing. The second thing that we do is going to be, and this is sort of the post lab of the experiment, which is also found in the report sheet, is to do conversions with those measurements. So just to remind ourselves how a conversion would look, let's go ahead, and since that's going to be our next quiz, that's the final piece of this puzzle, which will be things like convert, say that I measured the length of my my calculator, and in the interest of time, I won't measure it, but I'll make up a number right now. Let's just let's say that it's about 15.43 because it was in between the lines. So perhaps it was in between the little 4 tick mark and a little 5 tick mark. So it's 15.43 centimeters. Let's practice converting that to millimeters. Okay. So whenever we do this, and you'll have space on your report sheet to do this, whenever we do a math problem in this course that involves units, we're going to try to organize before starting, because that always helps us sort of orient ourselves or focus ourselves. So first we're given, and in this case, it's 15.43 centimeters. We desire units of millimeters. Now, I want you to always be using the table that I gave you to do these problems. Please don't try to go Google what is this many. I mean, surely you could find it online, but we're trying to practice the method that extends beyond this, and it goes into our other chapters. So what we're going to do is you're going to use the table only to see how do I get centimeters to turn into millimeters. Now, one thing we notice is that the centimeter line only talks about turning centi into the base unit. So that entry row for centimeter that we see tells us that there are 100 centimeters equals 1 base unit. And if we're talking about meter as our distance measurement, then centimeter goes to meter, take off the prefix. So we have that. Additionally, when I look for a milli, I see something else. I see there are 1,000 millimeters in a meter. So do we remember the phrase for what our strategy is going to become? We call that a chain conversion. So instead of being a one step, we're going to have to connect the conversion factors, those fractions, for 2 steps together. So that's going to be how we work. I can go from centi unit to meter unit. So that's going to be what I do, centi to meter. The other row tells me the relationship, how they connect meter to millimeter. So that's the flow of how my units are going to change. I'm first going to change centi to meter, and then I'm going to change meter to millimeter. So let's go ahead and put that together as math. 15.43 centimeter. And then our rule is we're going to do math with fractions. So it's a fraction that we call a conversion factor. It gives us the relationship as a fraction. So that relationship is 100 centimeters makes a meter. How are we going to put this information in? We want to make sure that our unit changes in the next step. So in order to do that, top and bottom of a fraction will cause canceling to happen. I want to get rid of centimeter to make meter. So I'm going to put it 100 centimeters is 1 meter. That's going to, whoops. Cause centi to cancel, giving me meters, which is sort of the in-between step in my flow chart. Then I'm going to set up the next fraction. We don't have to write a new line. When it comes to multiplying, you can do all of the multiplying all at the same time. So I'm just going to add the next multiplication. Well, maybe I shouldn't use both words in the sentence. I'm going to combine multiplication. So I'm going to put another fraction in. This is times. And I'm going to say a meter is 1,000 millimeters. Why? Because those are the numbers that go with each unit. And I want to put the fraction so that top and bottom cancel. And that's going to happen here. When we plug that into our calculator, we could either simplify ourselves or let our calculator simplify, but we're going to do 15.43 times 1,000. The ones are optional to put into the calculator, and then divide by 100. So that should come out to be 154.3 millimeters. Now, one last thing to check is that a prefix conversion will always abide by the significant figure rules because it's a multiply. So we have to just double check. And this is the other thing that I will be double checking when you submit is do your sig figs match the rules that we have? So our rule is we count the sig figs of everything we've used. 15.43 has 4 significant figures. The prefix conversions are definitions. So those have infinite and infinite. So that means our answer must round to fewest sig figs. So that's equals 4 significant figures. That's the other thing I'm going to be looking for. So just to reiterate, are you using the ruler correctly and writing the digits down correctly? That goes back to our lab lecture number 1. That was all about that, if you'd like to go and look at that again. Secondly, you'll be doing conversions. I'm going to look that you're using the table that I gave you and not just Googling numbers. So that's coming there. And third, I'm going to be looking for that you're rounding correctly. When it comes to a prefix conversion, the significant figures going in are the same as the significant figures going out. This might mean that you might have to add zeros to make sure the significant figures are still valid, right? So that may or may not happen. So those are the 3 things that I'm going to look at. So maybe I should just write that down as an emphasis. So, looking for correctly reading ruler to correct decimal places. Always, not just sometimes, but always. The second thing I'm looking for is using conversion factors from class. It will ask you, well, can you turn this centimeters into kilometers or so forth? And then finally, always using rounding rule for final answer. Okay, so those are the 3 important things. This experiment might seem simple, but looking at these criteria, it does take a little bit more work than you might think. So at this point, that's what I wanted to just relay to everyone, to sort of give everyone this information as we go forward with our virtual, or I guess this is at home experiment. So the idea is you're going to find 3 objects. You're going to use your ruler correctly. You're going to write down that information. And you're going, information meaning the lengths that are asked for. And then you're going to be performing some math, being careful that you're going by the rules of our lectures. So lab lecture on the very first one we did, number 1, was reading the ruler correctly. And conversions is part of lecture 2, which we will actually continue and still work on that tomorrow in lecture. At this moment, maybe I'll pause in case there's a question on what exactly is going on with experiment 1. I can repeat, or if there's something specific about related to measuring things with a ruler. And I'll just pause for a second. So, okay, if something comes up, I'm still looking at the chat in case someone's typing as I speak. The last thing that I will note about experiment 1 is the idea is to get comfortable with the habit of always checking that you're reading something correctly. And then practicing the rules of using significant figures and decimal places, not just as the end of a question, but as part of a bigger question now. So you see how we're building on the information. Now that we're having more comfort practicing significant figures, now that's only going to be a tiny portion of a bigger problem. And so that's kind of how we're expanding with this. So that's going to be experiment 1. What I will do is leave it for you to take a look at that and begin experiment 1 in this period. And if you have any questions, please Canvas message me so that I can answer them. Reminder that experiments aren't meant to be sort of in a vacuum. You're completely alone with them. You can always come to office hours and ask me for help, okay? Even if it's a matter of, I did this math in my report sheet, but I'm not feeling confident, or could you just help me sort of make sure that step 3 is what I'm supposed to do? We can always do that together. So I don't want you to feel like you're all alone with these experiments. When we're in person, I'll definitely be there right by your side to help you if you need anything. But even in these virtual experiments, I'm still here. So let me know how you're doing and how measuring the ruler with the ruler is going. But with that, I'm going to end our lab lecture on the experiment. And I ask that you look for it. I do give the at-home experiments more time than the in-person. So you do have a weekend essentially to get it done. However, don't leave it to the last minute, please, please, please. This is something that you could easily get done in this time period and then have all your questions ready for an office hour at the end of the week to discuss. Okay. But with that, I'm going to stop the recording, but if there are any other questions while we're still here, I can answer them. But this will be the conclusion of today's lab period. Okay, so I'm going to go ahead and stop.